Okay, in static calibration, we have three different types of calibration. They are transducer calibration, data system calibration, physical end-to-end calibration. In transducer calibration, we mainly focus on the transducer's input and output relationship. It is done on each transducer to verify that they perform as the transfer function describes. If the result deviates from transfer function, necessary zero and span adjustments are carried out to correct them. The transducer calibration is carried out under the assumption that the wiring and the signal conditioning will function as designed, but one bad connection invalidates the data. Hence, it is not recommended to depend solely on the transducer calibration. The second type is data system calibration. For making valid engineering measurement, the most important consideration is how the transducer operates in the actual test environment with the entire signal conditioning equipments attached. Although not always it's feasible, the transducer should be calibrated while connected to the same signal conditioning equipment in the laboratory as it will be used on the actual test article. This type of calibration stimulates the desired measurement rather than the physically stimulating the transducer's sensing device. The third type is physical end-to-end calibration. Physical end-to-end calibration is the best method of ensuring collection of valid data. Engineers generally perform this calibration after installing the transducer in the actual instrument where it is to be used. It mainly checks the measurement system installed on the test article so that the engineer can identify and correct many potential problems at an earlier stage. Okay, next we will see what is meant by error and what are the different types of errors available. Generally, error is the difference between measured value and the true value. Generally, no measurements can be made without any error. By knowing the amount of error, the error can be minimized to the maximum possible extent. It's very important to know the source of error before we are going to eliminate it. The three main types of errors are gross error, systematic error and random error. First, we will see about what is gross error. Gross error. It's mainly occurred due to the human mistakes. These errors occur during noting down the readings and during making the calculation. It can't be treated mathematically and we cannot eliminate but we can minimize this error. Example, when we are using the instrument in an improper way, the error occurrence will be high. If we are using it in a higher conscious rate, the error occurrence will be low. In general, the indicating instruments change with ambient conditions to some extent when connected into a complete circle. Therefore, several readings must be taken to minimize the effect of ambient condition change. The next one is systematic error. These errors occurs due to the shortcomings of the instrument, such as it can have a defective or own parts, aging or effects of the environment on the instrument. It is further subdivided into static error and dynamic error. Static error are caused by the limitations of measuring device, whereas dynamic errors are caused by instrument not responding very fast enough to follow the changes in a measured variable. Okay, it is further classified into instrumental error, environmental error and observational error. When we see instrumental error, it is inherent while measuring instrument because of their mechanical structure. It occurs due to the misuse of instruments due to the loading effect of the instrument. We can avoid this error by selecting a suitable instrument for a particular measurement application, then applying correction factor by determining the instrumental error, then calibrate the instrument against the standard. The next is environmental error. Environmental error occurs due to the conditions external to the measuring device. These errors are due to temperature, pressure, humidity, dust, vibration, external magnetic field and electrostatic field surrounding the instruments. We can avoid this error using air conditioning, sealing certain component in the instrument or using magnetic field. The next is about observational error. It is introduced by the observer. Most common error is parallax error and estimation error. For example, an observer can hold his head too far to the left while reading the position of the needle on the scale. Then third type of error is random error. This occurs due to unknown causes or occur when all the systematic error has accounted. It leads to the accumulation of small effect and it requires high degree of accuracy. We can avoid this error by increasing the number of readings, and we can use statistical means to obtain best approximation of the true value. These errors are unpredictable that may or may not occur. Now we will see what is meant by transducer. A transducer is a device that converts one form of energy to another form. It converts a measurement to a usable electrical signal. It is a device that is capable of converting physical quantity into a proportional electrical quantity such as voltage or current. For example, when you are applying pressure to a transducer, it will convert the pressure into a voltage. Here we will see a video illustrating the application of a transducer and its working nature.
What is a transducer? At an airport and some restaurants, we see automatic doors which open automatically, so we proceed towards it. Have you ever thought how such doors operate? Let's try to understand this. Such doors consist of an infrared ray emitter, which radiates invisible rays. The emitted infrared rays are reflected by a person proceeding towards the door. The reflected rays are then received by a device, which converts them into electrical energy. This electrical energy then energizes the motors connected to the door, thus opening the door automatically. Such device, which converts light energy into electrical energy, is known as transducer. Thus, we can say that transducer is an electronic device which converts energy from one form to another. Some of the examples of a transducer are phototransistor, which converts light energy into electrical energy; LVDT, which converts translational motion into electrical energy; and thermistor, which senses heat energy into electrical energy.
Now we will see what is the difference between a sensor and transducer with the help of the video.
What is a transducer?
Measurement is an important subsystem of a mechatronics system, which is used to collect the information on system statuses such as temperature, humidity, pressure, or proximity, and is fed to the microprocessors for controlling the system. A transducer is an essential part of any information processing system that operates in more than one physical domain, such as optical, electrical, magnetic, thermal, and mechanical domains. A transducer in general is defined as a device that converts one form of energy into another using the transduction process. The transduction process or function represents the characteristics or properties of the device used for energy conversion. For example, the diaphragm in a microphone converts vibrations generated by sound waves into electrical signals. This property of the diaphragm is represented as a transduction function or process. A transducer has at least one input and one output. In measurement system, information processing is performed by electrical signals, with either the input or the output is of electrical nature such as voltage, current, resistance, capacitance, and so on, whereas the other is a non-electrical signal such as displacement, temperature, elasticity, and so on. A sensor is an input transducer with a non-electrical input, intended to convert a non-electrical quantity into an electrical signal in order to measure that quantity. For example, a thermocouple, which is a temperature sensor, converts non-electrical input, that is the temperature, into an electrical signal, that is voltage. An actuator, on the contrary, is an output transducer with an electrical input, intended to convert an electrical quantity into a non-electrical signal in order to control that quantity. For example, an electric pump or motor converts electrical input, that is the voltage, into non-electrical output, that is rotational motion. Bidirectional transducers are capable of converting physical quantities into electrical signals and vice versa. For example, antennas in the transmitting mode convert the electrical signals into radio waves, while in the receiving mode converts radio waves into electrical signals. It should be noted that this terminology is not standardized. According to Vocabulaire International de Metrologie, VIM, transducer is a device used in measurement that provides an output quantity having a specific relation to the input quantity. The same document defines sensor as the element of a measuring system that is directly affected by a phenomenon, body or substance carrying a quantity to be measured. The term sensors and transducers are used interchangeably often. However, there is a slight difference in them. A common statement which is largely used in engineering states that all sensors are transducers, but not all transducers are sensor. Essentially, all sensors are transducers as they convert physical quantities into electrical quantities, conversion of one form of energy into another form. But not all transducers are sensors, as in case of actuators, where there is also the conversion of one form of energy into another form, but are not capable of sensing, rather are used for controlling. Let us now understand the difference between sensor and transducer when used as a measuring system. In a measurement system, a sensor is defined as a device that converts the physical quantity, usually non-electrical input, to be measured into directly an electrical output. For example, a piezoelectric pressure sensor will sense the pressure, physical quantity, into voltage, electrical output, through transduction process. No conversion of the output of the transduction process is required in this case. On the contrary, a transducer in a measurement system is defined as a device that converts the physical quantity, the non-electrical input, into an electrical signal such as resistance, capacitance and so on. This electrical signal obtained from transduction process needs conversion to make the signal usable through use of a signal conditioning circuit. For example, a RTD is a temperature transducer that senses temperature, the physical quantity, and converts it into resistance. A signal conditioning circuit such as Wheatstone bridge is required to convert resistance into voltage. This is a small difference between sensor and transducer when considering a measurement system. Hope you liked this video. Kindly subscribe to my YouTube channel and press the bell icon so that you won't miss any of my video. As a self-assessment task, classify the following devices as either sensors or transducers when considered as a measuring system. See you next time. Happy.
This is the general block diagram of the transducer. The transducer generally consists of two parts. Those are sensing element and transduction element. The sensing element is also known as sensor. It is a device that produces measurable response to change in physical condition, whereas the transduction element is used to convert the sensor output to a suitable electric form. For example, if you are going to measure any temperature or pressure or force, that is given as the input to the sensing element. The sensing element will produce the output, and that output is fed to the transduction element. In the transduction element, either pressure, temperature or force gets converted into an readable electrical signal. Now we will see the different characteristics of the transducer. The different characteristics of transducer are ruggedness, linearity, repeatability, accuracy, high stability and reliability, speed of response, sensitivity and small size. First we will see what is meant by ruggedness. Ruggedness is generally defined as that the transducer should be mechanically rugged in nature to withstand the overloads. It should have the overload protection. The next one is linearity. Linearity means the output of the transducer should be linearly proportional to the input quantity which we are going to measure. It should have a linear input output characteristics. The next one is repeatability. Repeatability is generally defined as the output of the transducer that must be exactly the same under the same environmental condition when the same quantity is applied at the input repeatedly. The next one is high stability and reliability. This plays a vital role in the characteristics of the transducer. That means the output of the transducer should be highly stable and reliable so that there will be a minimum error in the measurement. The output must remain unaffected by the environmental condition such as change in temperature, pressure, etc. The next one is speed of response. Speed of response is defined as the rapidity with which the transducer responds to the change in the measured quantity. The speed of response of the transducer should be as high as practicable. The next important characteristics is sensitivity. Sensitivity is generally defined as the electrical output obtained per unit change in the physical parameter of the input quantity. For example, we can consider a transducer which we are going to use for temperature measurement. The sensitivity will be expressed in millivolt per degree Celsius. A high sensitivity is always desirable for a given transducer. The last one is size. The transducer should have the smallest possible size and shape with the minimal weight and volume. This will make the measurement system very compact. Next we can see about the different selection factors that we are going to consider while selecting a transducer. The first one is operating principle. The transducer are selected on the basis of operating principle which we are going to use. The operating principle may be resistive, inductive, capacitive, optoelectronic, piezoelectric, etc. The next one is sensitivity. The transducer must be sensitive enough to produce detectable output. Operating range. The transducer should maintain the range requirement and have a good resolution over the entire period of usage. The next is high accuracy. Accuracy plays a vital role in selecting a transducer. The transducer should possess high accuracy. Next is about cross sensitivity. It has to be taken into account when measuring the mechanical quantities. There are situations where the actual quantity is being measured in one plane and the transducer is subjected to variation in another plane. The next is error. The possibility of error occurrence should be very low when you are going to select a transducer for measuring. It should maintain the expected input-output relationship as described by the transfer function so as to avoid the error. Next is about transient and frequency response. The transducer should meet the desired time domain specification like peak overshoot, rise time, settling time and small dynamic errors. Loading effect. The transducer should have a high input impedance and a low output impedance to avoid the loading effect. The next is about environmental compatibility. The transducer that we are going to select should be compatible with the environment. It should maintain a proper input-output relationship with the environment and it should not break down during working. The last is about insensitivity to unwanted signal. The transducer should be minimally sensitive to unwanted signals and highly sensitive to the desired signals. Now we will see about the classification of transducer. Transducers are generally classified as active and passive, analog and digital, primary and secondary, transducer and inverse transducer on the basis of transduction principle used. Now we will see what is meant by an active transducer. These transducers do not need any external source of power for their operation. They are also known as self-generating type transducers. They operate under energy conversion principle. As the output of active transducer we get is equivalent to the electrical output signal. For example, we are measuring temperature or strain to electric potential without any external source of energy being used. The active transducer is further classified in active transducer example are as follows: photovoltaic, thermoelectric, electromagnetic, piezoelectric, chemical, and other type of transducer. The next is about passive transducer. These transducers need external source of power for their operation, so they are not self-generating type transducer. A DC power supply or an audio frequency generator is used as an external power source. These transducers produce the output signal in form of variations in resistance, capacitance, inductance, or some other electrical parameter in response to the quantity to be measured. For example, we can consider LVDT. The passive transducer are further classified into variable resistance, variable reactance, optoelectronic, and a Hall effect type. The next is about primary and secondary transducer. Some transducers contain the mechanical as well as electrical device. The mechanical device converts physical quantity to be measured into mechanical signal. Such mechanical devices are called primary transducer because they deal with the physical quantity to be measured. The electrical device then converts this mechanical signal into corresponding electrical signal. Such electrical devices are known as secondary transducer. According to the transduction principle, it is classified. Transduction is further classified as capacitive transduction, electromagnetic transduction, inductive transduction, piezoelectric transduction, photovoltaic transduction, and photoconductive transduction. And the next one is transducer and inverse transducer. Transducers generally convert the non-electrical quantity to electrical quantity, and inverse transducer converts the electrical quantity to a non-electrical quantity. The analog and digital type transducers are the analog transducer whose output is a continuous function of time. It's called as analog transducer. Some examples of analog transducer are strain gauge, thermocouple, LVDT, and thermistor. In digital transducer, the output is in the form of pulses. These are known as digital transducer. The output of the digital transducer, being binary in nature, can be easily represented either by opaque and transparent areas on a glass scale or by non-conducting and conducting areas on a metal scale. Glass scales can be read optically by means of light source, an optical system, and photocells. The metal scales are scanned by brushes making electrical contact with the individual tracks. Thank you.